Hello, it's Dr. Smith, and today we are going to be learning about the chain rule. This is used to differentiate equations. So let's get started. The chain rule states dy over dx equals dy over du times du over dx. What does this mean? Well, let's take a look at it. So we know we have x and y, and in this equation that we're going to differentiate, we have x and y. But you see we have another variable, a u. Like, where does that come in? And so what u is going to come into play is it's going to be our inner function. And I'm going to explain that to you right now. What do I mean by the inner function? If we look at this equation, y equals the quantity of x squared minus 4x raised to the third power, we see that we have an inside part, inside the parentheses, and we're going to call that u. And then we have the whole outside part, which is raised to that power of 3. So we have an inside and an outside. And when we use the chain rule, what we're going to first do, number one, is differentiate the outside first. So we're going to have to differentiate this whole entire thing, keeping the inside, the inner part, the same. Then we're going to differentiate the inner part, which is our u. So what I'm going to do is I'm just going to pull out u over here. Our inner part is just that x squared minus 4x. All right, we're going to come back to that. But first, let's take the derivative of the outside part. So u prime equals... So if we just look at this outside part, this is 3. This is really a 1 here. So 3 times 1 is 3. X squared minus 4x. We have to keep that inside part the same. And then 3 minus 1 is 2. So we've done this first step. Perfect. Now we have to multiply it by the differentiation of the inside part. So here's our inside part. All I did was I just pulled it out. So we need to find that du over dx. That's this part right here. So we've done the outside part. Now we have to do the inside part. So this equals, let's do each of these separately. So x squared becomes 2x. Negative 4x becomes minus 4. So here's the differentiation of the inner part, 2x minus 4. And we're done. Now, some professors in college courses might want you to multiply this out. And that is possible. They might want you to multiply it out and then combine like terms. I am going to be doing that a little bit later on, but just not for this example. I'm just going to leave it as is because it's differentiated. So let's move on to our second example. Number 2. We have y equals the square root of the quantity 5x squared minus 2. So before we do anything here, let's change that square root to 5x squared, the quantity of 5x squared minus 2, to the 1/2 power. We don't work with square roots when we differentiate. We have to turn them into powers, into exponents, so that turns into 1/2. Okay, so let's locate our inside part. Here's our inside part. This is our outside part, the whole other part of it. Let's write down our inside part on the side. Perfect. Then let's come back here and differentiate the outside part. This is a 1. So 1/2 times 1 is 1/2. Then we are going to just write 5x squared minus 2. Because we keep the inside part the same. Keep inside part the same. And then 1/2 minus 1 is negative 1/2. Okay, now we have to go and look at this inside part. Du over dx equals, do these separately. So 5x squared, so that's going to be 10x. Because 2 minus 1 is x, and then that drops out. It has no variable, so this is just times 10x. Now I'm going to do a little rearranging here just because I can simplify. So I see that I can take 1/2 of 10x. What's 1/2 times 10? And you guys are going to say 5, so this becomes 5x. So I'm done with that and that. I just combine those. 1/2 of 10 is 5, and I brought down the x. And then I see this has a negative, so I'm actually going to write it a little bit smaller for everybody. I didn't make a mistake. I'm just writing it smaller. So this would be 5x over, because this is a negative power. So remember, negative powers, that belongs now in the denominator. It is a square root, so I am going to put the square root, 5x squared minus 2. Put a little box around it. There you go. So I just rewrote it a little bit. I did combine some terms. I multiplied 1/2 times 10, and I got 5x. I notice that the negative puts the 5x squared minus 2 in the denominator, and 1/2 power, that is the square root, so I rewrote it with the square root. I like that answer much better than this one. I don't like writing answers with negative exponents very often, so we're going to try not to write answers with negative exponents. Okay, on to our last one for today. Y equals 2 divided by the square root of 1 minus 3x. So, right, a couple things I'm going to do here. So, y equals, I'm going to keep that 2, times 1 minus 3x. Now, it's in the denominator, and I'm bringing it up to the numerator. So, yes, it's negative, and it is a square root. So, just like we did before, 1/2. So, the negative is because I brought it up, and 1/2 because of that square root. And this is times, so that does have a coefficient in front. So let's read, now we have an inside part, u, and we have the whole outside part. This is the whole part is the outside. So let's rewrite the inside part, 1 minus 3x. We'll come back to that. Let's differentiate the outside part. So 1/2 times 2 is -1, parentheses, keep the inside the same. 1/2 minus 1 is -3/2. Okay, that outside part is done, so let's go over here. Du over dx equals 1. That differentiates, that's out. And then minus 3x just becomes -3, -3. Let's combine some things here. So -1, we can multiply it by 3. Y prime -1 times 3 is 3. And then we're going to do this over, okay, because remember, this is negative, so it's over, and we can write it as 1 minus 3x to the 3/2. And that is a 3/2. Let me just rewrite it for you because it looks a little messy. 3/2. Okay, now, some college professors or even high school calculus teachers might say, we don't want that fraction. So you could change it to y prime equals 3/. Now remember, when we have a fraction, 3/2, it's exponent over root. Let me move that over. It's exponent over root. So the root is 2, so that's a square root, and the exponent 1 minus 3x to the 3rd power. So if you didn't want this fraction as the exponent, it would turn into a square root, and this would be raised to the 3rd power. Either way, I will take in this course either one that you want to do. So that's about it. So this has been differentiation with the chain rule and a little bit of simplifying with our square roots and our negative exponents. Hope it helped.